Good afternoon, ladies and gentlemen. Thank you for coming. And I'm Kai-Chen Yan from Formosa Plastic Corporation. And today I am very honored to have this opportunity to introduce our latest product, intermediate carbon fiber TCA80. And we're targeting in the lightweight and advanced composite applications. And because maybe some audience doesn't know our company, so I will spend several pages to introduce us more, to make you know us more. And so here's my content. So I will introduce our Formosa Plastic Group, and to next introduce our carbon fiber and explain this some advantage, history, and recent breakthrough, and also our capability. So the last one might be the focal point of today's presentation, our new product, TCA80. So here's the Formosa Plastic Group overview. And currently we have 5 main companies. And with the first entity, Formosa Plastic Corporation, founded in 1954, and by these two Wang brothers. And starting from the PVC manufacturing and sales already, over the subsequent decades, we expand vertically and horizontally to enter different industries. Like in the Nanya company, we have secondary and tertiary plastic processing, and also in FCFC, we have many textile fibers. And in the PCC is our upstreams raw material manufacturer. They produce the raw material from the oil refinery. And this company is the first private oil refinery company in Taiwan, with the capacity ranked in top 10 globally. And in 2008, we established the steel industry to diversify into the steel company. And here is our company within this group distribute across Taiwan is our headquarters, China, Vietnam, and USA, and others company group information for your reference. So here's the product overview for our groups. And our philosophy is the vertical integration and also the horizontal to diversification. So we have the products from the petrochemical like propylene. This is the starting material used for carbon fiber. And also the chemicals like AN, and also the raw materials for carbon fiber, and plastic and textile fibers. And to support the operation of the group and also to contribute to the society, we diversify into the electronic industry, like in the transportation sector, and also the information service, and also the medical and education. So now we want to focus on our company, Formosa Plastic Corporation, where the carbon fiber belongs to. Our company have 2 segments, plastic segment and also the chemical segment. And in plastic segment, we have divisions for plastic and polyolefin and polypropylene. And their products support the medical, automobile, and also the like solar energy and textile. Like today, the jacket what I'm wearing is fully polypropylene, so it could help the recycle easier. You don't have to take parts that you don't have to set the part, and you don't have to spend time to take parts that. So take parts separated, so it's easier for recycle. And in the chemical segments, we have the Terran division produce the acrylic acid, normal butanol, and a super solvent polymer (SAP). And for the carbon fiber, it also belongs to the Terran division. So the Terryfield is our product name. And we also have the chemical division produce acrylonitrile. And in our electronic material, they established the AOI technology to support all the plants and also the process monitoring system. And also in our instrumentation center, we have established precision instruments to help the develop and inspection analysis of the all the products belong to our group. So here's the process for carbon fiber production from the very beginning, oil refinery from our PCC, and then propylene and acrylonitrile. And then the acrylonitrile will used in our division for produce the precursor and then carbon fiber. And this whole process could be accomplished in our group. So I have to emphasize here that we are the only one company could achieve such vertical integration from the oil refinery to carbon fiber. And this is the aerial photograph of our plants, industrial plants in Taiwan. And it's 8 kilometer in length and 4 kilometers in width. So we have our own harbors. We import crude oil to do the refinery to get the propylene and then acrylonitrile and PM precursor and carbon fiber, all inside this complex. So our development of the carbon fiber could be traced back to 1985. So starting from the initial capacity of 100 tons. So after several expansions to support different industry. So initially we support mainly sporting goods like maybe this year is the Olympic. Many our products support like badminton or tennis racket, something. And currently, our capacity is 7,650 tons. And during past few years, we dedicate effort to develop the dry jet waste beam precursor technology. So based on this precursor technology, we will have a new carbonization line next year and start production next year. We send 1,600 tons increase in capacity. So here's the overview of our carbon fiber products. So we cover from the small tow 1.5K and to the large tow 48K to support all kind of industry. And also the standard modulars, intermediate modulars, and high modulars. And the two products I highlight here is based on the new technology, dry jet waste beam. And I will explain in detail later. So why we want to establish this new technology? Because we see the growing demand in pressure vessel, and especially in the higher pressure vessel like hydrogen, 700 bar hydrogen vessel. The dry jet waste beam is required to dominate it, but we could see there's not so many stable such kind of carbon fiber manufacturer available, and also we see we have the ambition to enter the aerospace. We want to install our fiber into the aerospace industry, and during the past years we already accumulated capabilities in. Some experience in the domestic advanced trend jets. So also we see the new opportunity in the thermoplastic-based composite in aerospace industry. So that's why we want to develop this new technology. So here I want to explain the breakthrough for the dry jet waste beam. Maybe some people doesn't know what is the difference between the dry jet and waste jet. In the past, our carbon fiber mainly from waste jet. And here's the first one, the top one is the illustration for the waste beam process. And so you could see the polymer solution was pumped into the water bath. So the entire spinning process is in the water bath, and the precursor will be the kidney shape. But for the dry jets was being processed, before the polymer was jetted into the water bath, there's a small air gap to keep the fiber circular shape in the spinning process. And this circular shape fiber will help the even stress distribution. So the tensile strength and also other mechanical properties will be better. But this is not the only difference in the wet jet and dry jet. So in the polymerization process, there also is a different solvent, longer time, and different molecular weights. And in the spinning process also has our own technology and stretching all special design, and it's also owned by our technology. Not only the precursor process development, also we established the instrumentation center to help the development. From the monomer ratio, we established the proton MMR to check the ratio and to check the polymerization, the monomer weights will be accurate for our demands, and also to understand the crystalline property, because it's also the crucial factor for the strength. So we established the wide-angle X-ray diffraction and small X-ray scattering. And to know the gravitation with the process condition, we established the micro-Raman. And to check the fiber roundness, we established the field emission SEM, and also coupled with the AI mapping method developed by ourselves. And the last one, the surface property. This is crucial for the adhesion to the sizing and raising. So we established the XPS and AFM to check the functional groups and the roughness. And I have to emphasize this, all the instruments owned, established by our company. And last year, we announced TC780 here in Jack Show last year. So here is the some mechanical properties for the TC780, TC780, and comparison with our wet jet TC33P. So we could see it shows the higher tensile strength and also elongation. And also the translation in vessel is higher than 95%. And here also shows that it's composite tensile strength for epoxy-based prepreg. Because in my previous slide, I said we see the thermoplastic opportunities for aerospace. So we developed the PAEK series resin compatible sizing to install this industry. And here is the tensile strength of the carbon fiber with PEEK resin for your reference. So we could see it's much improved in the especially for this PEEK composite. And now this product has been qualified to use in the CNG Type 3 vessel, but also on the way in the hydrogen vessel assessment and qualification. And it also used for the simple prepreg and very low fiber area weights. And also it was authorized to produce the PEEK UT tape and also the LFT. I think they are both the potential materials for aerospace. So now we are arrived the focal point of today's presentation, the new product, TC880. And building upon the TC780, they use the same precursor technology. And it shows higher than 95% roundness. And such kind of dry jet iron fiber is not so, it's not everywhere, it's still available in the market. And so it has higher impact industry, which helps for the aerospace. And also the longer elongation and higher strength is beneficial for pressure vessel. And different from other iron fiber, our fiber exhibits larger diameters and so help the fiber uneasy to break. So it will be easy for our manufacturing process control. So it's a cost competitive fiber. And also shows the better fiber wear resistance because uneasy to break for the larger diameter. And also it shows the higher yield test. So So it shows a higher process efficiency. Here I summarized all the carbon fiber properties of our dry jet intermediate fiber TCA80, and you could see its diameter and yield tests are similar to those for our TC780, our standard modulus fiber, and different from our weight jet intermediate fiber is larger in diameter and yield test. And also you could see the tensile strength for TCA80 is higher than TC42S, our weight-jet iron fiber. And also the composite, epoxy-based composite. And the table here shows the summarize of the composite property for your reference, the tensile, fracture, and compression, and IRSS for your reference. So this fiber has been evaluated in several applications, like high pressure vessel from Hypercom and also the ANSYS in Taiwan. And all got a very good fiber translation, higher than 90%. And also it shows the 6% increase in the pressure vessel compared to our standard modulus fiber at the same winding pattern. And also, if we fix the burst pressure by using this iron fiber TCA80, we could see the 8% weight saving. So it's helpful to reduce the weight of the vessel. Maybe in some field, they need lighter vessel, and also beneficial for increase the hydrogen storage density. And for the thin ply prepreg already evaluated by the bicycle OEM in Taiwan, and it could achieve a low fiber error weight of 55 with no fuzzy occurred. And also to achieve the same FAW, we could save 30% to 50% spools because we have a higher yield test. And also it's beneficial for lighter weights and also save the crew cost. And for aerospace, already we evaluate in-house, and we can see the 13% increase in compression after impact CAI, which is crucial for the aerospace industry. Also for the thermoplastic, we already prepared the compatible sizing for this field. Here's our carbon fiber global footprint. And we are based in Taiwan. We manufacture fiber precursor here with the vertical integration tech advantage. And also to support our customer and to show the lead time, we established warehouses in the United States and also the Europe in the Netherlands, Rotterdam. And also we established a joint venture with Swanco in China. We produced the prepreg and protrude profile. Thank you for your listening, and we look for the collaboration partnership. Thank you.